When you made your name tag, you were using functions in CodeWorld. Today we're going to expand on that, and you'll learn how to make your name tag more complex by changing the thickness of the shapes like this one did. Let's start by learning a little more about functions. You have already used the drawing of function, the circle function, the rectangle function, the text function, and the ampersand, which is also a function. A function is like a machine with a specific job in which what you put in determines what comes out. The circle function takes a number and uses it to make a specific sized picture of a circle. The rectangle function takes two numbers and uses them to make a specific sized picture of a rectangle. The text function takes the symbols that you give it and makes them into a picture. The ampersand combines pictures and flattens them into one. The drawing of function takes your whole picture and draws it on the screen. So a function is a relationship that associates any possible choice of arguments with a unique result. Functions are important in computer programming, math, and other areas because they allow us to create and modify stuff in a predictable manner. They take an input and then based on that input, create a new output. It maps a set of inputs to a set of outputs. Here you see an example of how the circle function maps the input, the size of the radius, to the specific sized circle picture. You can see the notation we use to describe this process at the top. The function name is in lowercase, circle, followed by two colons, which mean has the type, then the type of input capitalized to the type of output, also capitalized. So it takes a number and turns it into a picture. So we would read this as the circle function takes a number and gives us a picture. We'll be learning and using a lot of different functions in CodeWorld, but they are everywhere. Functions are everywhere. Here's some other examples written in CodeWorld notation. An ATM, a money machine, takes a number, the number that we type into it, and gives us money, a very specific amount of money that matches the number. A light dimmer takes the switch position, so whatever we turn the knob to or slide the switch to, and it gives us a very specific level of brightness. A remote controlled car takes a lever position and gives us a specific speed that correlates with the lever position. Or a paint machine. If you've ever gone to Home Depot or Osh, they have those paint machines where you say, oh, I want this color, this blue, and then they type in some numbers like the amount of blue, the amount of green in it, the amount of gray in it, and they give you a very specific color of paint. So a paint machine takes a number and it gives you a specific color. Or even a restaurant, you give the waiter a word like enchiladas, and they bring you that very specific food, enchiladas. Those little wind-up toys are functions. They take a number of rotations, so however many times you turn the knob, and that determines the duration. So it takes a number of rotations and gives you the duration of it walking or moving. Even a food can be a function. So take the process of fermenting something. So fermented is the function, and it takes cacao and turns it into chocolate. Or it takes soy and turns it into tofu. It takes cabbage and gives back kimchi after it goes through the fermenting process. Or it takes grape and turns it into wine. So that fermentation is a function. It's a process that turns one thing into a very specific other thing. All right, now see if you can think of any other functions. Brainstorm alone for a minute or two and write down as many as you can think of, and then as a class write them on the board and determine if they are functions or not. Remember that in order for it to qualify as a function, it can only match one input with one specific outcome. A vending machine would not be a function, because if I put in $2, there are a lot of possibilities that could come out for those $2. But each specific candy button is a function, because if the button is pushed, the same thing would come out every time. All right, now pause the video and brainstorm as many functions as you can think of. Let's look at this circle diagram again. Inputs can be called by many different names. Programmers use the word parameter, but in CodeWorld, we're going to use the term argument to mean the input given to a function. These arguments are placed inside parentheses. Every function in CodeWorld takes a specific number of arguments. This table was made from the cloud you were just looking at. Let's check it out. Again, the notation at the top says the circle function takes a number, the argument, and gives us a picture, the result. How many arguments did the circle function take? That's right, 1, the radius. I used decimals here to create tiny circles. If I give the circle function a 0.6 argument and it returns a circle with a radius of 0.6, then if I give it a 0.5 argument, the function gives me a circle with that radius, and so on, all the way down to 0.1, where the result is this tiny little picture of a circle. Let's look at rectangle. So rectangle takes two numbers and gives you a picture. How many arguments does it have? Two, the width and the height. We see in the first example on the first row that the first number is 6, the width, and the second one is 1, the height. And the rectangle function gives us a rectangle that is 6 units wide and 1 unit high. I changed the first argument of the next one, and it gives me a rectangle that is 5 units wide and the same height, 1. As I make the first argument smaller, my rectangle is less wide. Notice the last one has the same number for both the width and the height, and the function returns a rectangle with equal sides, otherwise known as a square. The text function has one argument, the text that we type into the quotation marks. The function then takes the text and makes it into a picture in your drawing. So the words or symbols that you use or write are considered a picture, like a stamp or a sticker that the text function puts on your drawing. In this example, each line of the joke would be a separate picture or sticker on that drawing. This next function operates a little differently than the others. It's called a binary operator. Again, think of each function as its own machine that has done a specific thing with the input. The ampersand, which is an and symbol, takes two different pictures and combines them, kind of like the plus symbol does in math. In this example, it takes a circle and a rectangle and flattens them into one picture. You have to be careful about what order you put them in because each layer is a picture, and whatever one you write first will be the one on top. If I write ball and box, the ball goes on top because it is first. If I write box and ball, the box goes on top because it was written first. Okay, now that you've learned more about functions, let's learn some new ones to use in CodeWorld. The first one fills in the shapes you've already learned. The function that creates a solid circle is called solid circle, making sure the S is lowercase and the C in circle is capitalized. The argument is the same as circle, taking only a radius size. Solid rectangle is the function you use to fill in your rectangles. Again, make sure that your function is always lowercase and that you have a camel case capital letter hump of the R sticking up to separate it from the first word. Again, it takes the same arguments, which are two numbers for the width and height. Obviously, you couldn't use these solid shapes in your name tag because the black name wouldn't show up over them. So perhaps you want to leave a white space in the middle, but have thick edges to your shapes. To make the edges of your shapes thick, you're going to use the function thick circle. So let's look at this table here. Thick circle is the name of the function with the C capitalized, and it takes two numbers and turns them into a picture. It has two arguments. The first one is the radius, same as before, and the second one is how thick you want your circle to be. And the result is going to be a picture with that radius and thickness. So in this first one, I use decimals because it has to be really small. But I did a radius of 0.4 and the thickness is 0.1. So it's a thin little circle. I kept the radius the same on all of these circles in this table and only changed the thickness so you can see how it affects the circle. So they're all 0.4, but as the thickness goes up, so does the circle get wider. Thick rectangle function works the same way. So it's thick, lowercase, capital R, rectangle. Thick rectangle takes three numbers and turns them into a picture. And the arguments are going to be, the first one is the width, the second one is the height, and the third one is how thick you want the lines to be, the edges of the rectangle to be. In this first one, we have a width of 6, a height of 1, and the thickness of 0.1, and you always have to hold the decimals ones place with a 0. The second one, I left them all the same height, but it's 5 units wide, and the thickness is 0.2, so you can see that the picture is a little bit thicker. And so on, I just changed the thickness 0.1 all the way to the end where you have the square 1 unit wide, 1 unit tall, and 0.6 thickness. Let's do a summary of all the functions we just learned. So we started with a ball in a box, a circle 5, and a rectangle 3, 3. And we'll change the circle to a solid circle by filling it in. So we're going to just write solid, capitalize the C, circle, run it, and you'll see the circle will become solid. Now notice that the ball comes first, so now you cannot see the box anymore. It's still there, that square is still back there, but it's behind this big solid dot, so that's why the order really matters. If we want to make a solid rectangle, we just write solid, capitalize the R, push run, and you see that we get a solid rectangle. It's still behind the circle, but since the circle isn't solid, you can see right through it to the solid rectangle behind it. To make a thick circle, we type in thick, capitalize the C on circle. It's already got a radius of 5, but we need to add one more argument, and let's make it 3 units wide. Push run, and now we have a thick circle with a radius of 5 and a thickness of 3. And to make a thick rectangle, we type thick, capitalize the R, rectangle. It's got a width of 3, a height of 3, and let's make the thickness 2 units wide. And we'll run that, and voila, you've got a thick triangle. Before you get started on your project, I want to give you a helpful tip, and this will make sure that you spell things right and type the functions correctly. And also, if you forget how many arguments or what types of arguments they require, it tells you when you use this tip. So what you do is when you're typing a function, say you want to type a rectangle, but you're not sure how to spell rectangle, you know it starts with an R, E, and then you're not sure if it's a K or a C. What you can do is push Shift spacebar at the same time, and you're going to get a drop-down list of all of the possible functions that it could be. So I'm going to look through here. Is it reciprocal rectangle? There it is. I see that it takes a number and gives me a picture, so I remember how many arguments it takes. And I can also click it and it completes the word for me. Let's try one more. Say I want to type a thick rectangle, but I can't remember how many arguments it takes, so I type THI, then I'm not sure how to spell it. Again, I push Shift spacebar at the same time, and all my options of functions pop up. And I see that it is thick rectangle, the very last one, and it takes 3 arguments, a number, the width, another number, the height, another number, the thickness of the edges, and it's going to give me a picture. And then I can click on it, it spells it for me, and I can type in my arguments, and easy as that. All right, now it's your turn to play around with these functions. Experiment with them, then go back to your name tag and see if you can make it more interesting, funky, and fabulous.